quadratics then. Okay, we're going to have a look at the quadratic function. Now, we've seen quadratics before when we were factorising. A quadratic is basically any function that has a squared term in it. So if we have ax squared plus bx plus c, that is a quadratic function, as long as the a is equal to 0. If we graph a quadratic function then, the graph will be of the form y equals ax squared plus bx plus c. And when we graph a quadratic function, we get a parabola. Now, a parabola will look like one of these two down here. A parabola is symmetrical, and it has a vertical line of symmetry. And we get two different kinds of parabolas. We can get one with a minimum turning point, like this. It's called a minimum turning point because it turns at the bottom of the function, so the lowest value that it gets is where it turns. And that is when our x squared is positive. If it's positive, we get a happy smiley face and a minimum turning point. The other way we can get is we get a maximum turning point where it turns at the top, and that gives us a maximum turning point, and that is when x squared is negative. So it's negative, it's a sad graph. Okay. These parabolas will sometimes have roots or zeros, and that's where it cuts the x-axis. Where it cuts the x-axis are known as the roots of the quadratic function. Quadratics are a major topic studied in maths. If you go on and do further maths after National 5, you will keep using them, keep studying them, keep looking at them. They are used all the time in real life as well. Parabola can be seen in science, it can be seen in engineering and architecture. Just a couple of examples. The McDonald's sign is made out of a couple of parabolas. Roller coasters will use parabolas as well. They are it's one of the topics that is used continually in real life. Probably not anywhere you've seen, but if you go on and study further maths, engineering, architecture, anything like this, you would use parabolas. Okay, what we're going to do then to start with is have a look at these two graphs, and all I want to do is write down the nature, the turning point, and the equation of the line of symmetry. So looking at the first one here, it turns at the bottom, so it's got a minimum turning point. So it's got a minimum turning point. I'm going to shorten turning point just to TP from now on, and the minimum turning point is at 3, 6. The nature of the turning point is where it turns. It's turning down the bottom. So I've done that bit, sorry guys. So it's a minimum turning point, and the equation of the line of symmetry, your line of symmetry goes right through here. It's a vertical line. Now back when we looked at the straight line, we looked at equations of horizontal and vertical lines. It's a wee bit everybody always forgets, but every single point on this line has an x coordinate of 3. So that equation, not that equation, I can't think my words today at all, that line has equation x equals 3. If we look at this one's turning at the top, so it's a maximum turning point, and it's a maximum turning point at -2, 5, and my line of symmetry goes through my x coordinate again, so it would be x equals -2. Oh, that was a dodgy 2. Let's try that one again. -2, that's better. Okay, we're going to have a look at solving quadratic equations then. There's 3 different ways of solving quadratic equations. We can solve quadratic equations graphically, we can solve them algebraically, and we can solve them using a formula. So today we're just going to look at solving them graphically. Now I'm not going to ask you to draw the graphs, I'm just going to ask you to solve them using this. Okay, so if we've got equation x squared minus 4 equals 0, we're looking for where the graph equals 0. It equals 0 where it crosses the axis. It crosses the axis at -2 and 2, so we get 2 solutions. We get x equals -2, x equals 2. Looking at the next one then, we're going to solve it, so we're looking for where it crosses the axis. It crosses at -3, and it crosses at 1. So my solution is x equals -3, and x equals 1. One more. Please don't try and make this harder than it is. It is as straightforward as picking out the values where it's crossing the axis. I'm not even looking at what the equation is, I'm not interested. I know I've got to solve when it's equal to 0, so I'm just looking for the 2 points where it crosses the axis. So we get x equals -2, x equals 0. Okay, I'll leave you to try some solving quadratic equations graphically. It shouldn't take you long to do the exercise on that. Once you've got the idea of a couple of them, move straight on.